I'm going to give you like an overview of the topics that we're going to speak tonight. And I'm going to start with an overview of some Spotify numbers. So we have currently 75 million active users, 20 million subscribers. We have a catalog of 30 million songs, and we're available through 58 markets around the world. About our iOS client, well, it's developed in average by 50 contributors every month, and it's roughly the size of 500,000 lines of code, and we can reach millions of users through this code. And the stories that you're going to listen tonight, I think they're very interesting because of the characteristics of our organization. And the first one is the scale that we work with. The scale both of the number of users that we can reach and the scale of the number of people working to accomplish this. The second characteristic is that we're the leading market on music streaming service, but in order to keep that, we need to continue innovate, and we cannot miss a step on this, or somebody else is going to grasp that market. And finally, what makes really tricky all these stories is that we work on a very modular organization, perhaps too modular. It's crazy. You see, we have all these features like radio or artist or player or so many others. And all of them, they are a highly autonomous team with everything they need to ship. They have QA, iOS, Android, test automators, designers, everything they need. All of them are self-sufficient and loosely coupled. And that's a really good thing, because you can, let's say, work in album and really you have the chance to really focus into it and tinker it, and at the same time perhaps ads is doing something different, and you really don't care about that because it's a highly modular, low dependent organization. We can all agree that's pretty cool. And how does this translate to the iOS development? Let me show you. So all these features are enclosed in a Xcode workspace, and they communicate to each other through a public API that is defined by protocols. So we replicate this organizational model in our Xcode workspace, and so far it works pretty well. One of the disadvantages perhaps that can happen is that these features can create silos of knowledge and hence silos of implementation. And through time, maybe these silos can grow far apart from each other, and standardization becomes a very challenging goal. But so far so good. Now, even with this approach of modular platform, it's still a very big team, and we still have lots of problems trying to tie together the work of all these engineers. And traditional work models like forks don't work as well anymore. So we have to move to something different. We have to move to future flags. And this means that instead of different branches, we have one single master branch where everybody commits their work and everybody commits the work in progress, but everything is hidden behind a future flag that we can just turn on or turn off. And we use this to ship new features, and we use this also to roll out new features or make tests about changes in the application. And what I like most about them is that we can just turn them on from the backend, and if something goes wrong, I guess it has never happened to you, we can roll them back almost instantly and contain the radius of damage that we're causing with our changes. Well, those are some particular challenges that we face with scale. But how is the journey of code from git commit to the user to when you're listening your favorite artist? Well, I made, I think, 6 steps, that I'm going to show you. The first one is that the step 0 is our agile flavor culture, where we plan in very short iterations what we're going to do. Some teams might use Kanban, some teams might use Scrum, whatever works best for them. And I mentioned it's a flavor culture because it's not like a very religious following of some practices. But once something is planned, then it's implemented by awesome developers like you, and this is where the fun starts. It's committed to our repository. We're currently using GitHub Enterprise, and we use a very similar model to your favorite open source project in GitHub. So it's like an internal open source model where everybody can contribute to our client. And once that happens, well, we start a code review. You think you have built something awesome, and perhaps your code reviewer disagrees a little bit, but together, well, you improve the quality of your software, and everybody's happy. And what we have learned about this? Well, we have learned that we can spread knowledge, which is very important because of our modular organization. We can prevent work from being done because in this modularity, sometimes we are repeating lots of work. And before it happens, code review can catch that. It's also, as you know, an opportunity to detect errors. And, oh, I lost my slides. Oh. Never mind. Thanks. And it's also a venue for technical discussions. Then, step 3. It's been reviewed, and our continuous integration is working. You probably know about it. It eases integration issues. It gives us notifications and stats on what's wrong. We have like really cool dashboards with lots of information, building times, running times, everything. It gives us very detailed clues of what went wrong, when, and they execute our suite of tests. And this suite of tests starts with our unit tests. So what's cool about them? Well, we have discovered that if we focus mainly on the model and the view model, they work best. It's our first channel of feedback against regressions. They can be executed on a developer's machine, so it doesn't matter if they're remote and if they're offline. And also, we have figured out that, well, we have noticed that testable code is better code. And once that has happened, we also have another line of defense against regressions. We have our automated test. So we have lots of simulators and lots of devices in different configurations, different screen sizes, and we have robots playing on them. No, it's not that fancy as like robots playing with them. This is how it looks, but it works. And well, these automated tests, they help us test the view components. They are executed in all the devices that we support. And an important learning is that they scale better if they are implemented by the developers. Traditionally, I think we had automated testers building these tests. But at some point, I feel like this might not scale as well as we wanted. So it's better when developers are responsible of testing a little bit of their code in an automated way. And so, once all these steps have happened, then your code is able to be merged to master and is able to reach all our users for them to listen their favorite music. And what's left for us? Then, well, it's just about monitor crashes and fixing them swiftly. And we're using Crashlytics in order to do that with pretty good results. And then, how do we measure that this is actually working? How do we measure that these practices are taking us in the right direction? Well, we have a shorter release cycle that changed from 3 weeks to 2 weeks. Also, the frequency of our crashes is so much lower before we started to implement all these practices. And my favorite metric is this one. We shifted from 3 stars in the App Store to a 5 stars application, except in a few markets. And now that you know this very short overview, my colleagues are gonna dive into some of these topics and explain you how exactly we do it.